All right, so this is going to be the last video associated with chemical reactions. And this is just having a little bit of an overview, a little bit of a review of how you can tell the different reaction types apart from one another. With precipitation reactions, you're always going to have ionic solutions as your reactants that are going to be soluble. And when you have a precipitation reaction occur, one of the new pairs of ions will end up forming an insoluble substance, also known as a precipitate. With acid-base reactions, you're going to have either a strong or weak acid or a strong or weak base present as reactants. When it's a strong base, you'll have water made, but whether you have a strong base or not, you will always form an ionic salt. With your gas-forming reactions, a specific subset of your acid-base reactions, you will have an acid that reacts with one of three types of salts, a carbonate, a sulfide, or a sulfite, and they'll end up making gases, CO2, H2S, or SO2. Or you will have a strong base react with a salt containing ammonium, and that one will produce ammonia gas. Redox reactions, again, are going to have that electron transfer taking place. Whenever you have a combustion reaction, whenever you have a single replacement reaction, those are always going to be redox. And again, your simple synthesis, your simple decomposition, where a compound is broken apart into its elements, or two elements come together to form a compound, those are going to be redox as well. But there definitely are examples of redox reactions that are not redox, that are synthesis and decomposition. You can also have, as you've seen in some of the examples where we balanced, where you have reactions that don't necessarily fall into one of those three categories above, or even into the categories we talked about with redox reactions. But as long as they have that electron transfer occurring, they will be classified as redox. So here are four examples. I just wanted you to go through and identify what type they were. So if we take a look at our first example, we have two ionic compounds, and then we have two ionic compounds as products. One of them is insoluble, so that would be an example of a precipitation reaction. In part B, we have an ionic compound reacting with an acid, and it's producing a salt, water, and CO2. So the gas forming should be a pretty good clue that that's going to be a gas forming reaction. It's a carbonate reacting with an acid. In letter C, we have magnesium, just an element, reacting with aluminum chloride. It forms aluminum and MgCl2. So magnesium has gone from being by itself to being part of a compound. Aluminum chloride, aluminum was in a compound and now it's by itself. And that's your classic redox reaction. This is just a single replacement where magnesium is more reactive than aluminum, so it kicks aluminum out of the equation. Finally, in letter D, we have an ionic compound with the FeOH3, and we have an acid, HNO3. They formed a salt and water. The ionic compound we started with was a base because it had hydroxide, and you're reacting it with another acid. This happens to be a strong acid, which is why you saw water form as well as the ionic compound. So that would be acid-base. Just because you have water form does not guarantee you that you are acid-base. You really need to take a look at what else is occurring. If you go back and look at part B, you can see water formed in that gas-forming reaction as well. So last thing I'm going to ask you to do, I won't ask you to predict products for single replacement, I promise, or for redox reactions, but predicting products for the other three that we spent time on this unit are fair game. So I want you to determine what the products would be for these three particular reactions and tell me whether they are precipitation, acid-base, or gas forming. So you have nickel carbonate with sulfuric acid. I didn't ask you to write these as net ionics. If I had wanted you to write them as net ionics, I would have definitely had to give you more information about their solubilities. But you've got an acid and you've got a carbonate, so that should kind of be giving you a clue that this is going to be a gas-forming reaction. And we know the gas is going to form as CO2. Nickel and sulfate are going to come together to make a compound, and we're also going to give off water. And if we look at that particular equation, I do believe it is balanced. You've got one Ni on both sides, one sulfur on both sides, one carbon on both sides, and 7 oxygens on both sides. In our next example, we have an ionic compound with a strong acid again, but this time the ionic compound is a base, so that kind of helps distinguish that from the gas forming reaction above. It's not just a salt that can act like a base, so it actually is a strong base. So we would have just the switcheroo where hydrogen hydroxide would make water, and cobalt and bromine would come together to make a compound. I can't talk, I'm sorry. Cobalt's +2, bromine's -1. That's why you had COBr2. When we balance this particular equation, we do need to have more bromines. And when we have those extra bromines, that's going to give us sufficient hydrogens and oxygens to make 2 water molecules. And then your last one, yes, you can pretty much guess is going to be a precipitation. You have 2 ionic compounds, but they're generic ionic compounds. You don't have an acid, you don't have a base. You've got to have both to be acid-base, and you need to have at least one of those with those either an acid with one of the 3 types of salts that we specifically mentioned with gas forming, or a base with ammonium salts to be able to be gas forming. So in this case, silver and chlorine are going to switch places to form a new compound, and sodium and acetate are going to form a new one as well. They're all +1 or -1 ions, and I believe your precipitate would be the silver chloride. So this would be an example of a precipitation reaction.